All right, ladies and gentlemen, so this is our formative 2, which was our formative on Newton's third law. And so if we get more specific and we remember that Newton's third law says for every action, there's an equal and opposite reaction. So for every action, there's going to be an equal and opposite reaction. So remember our examples in class were things like if I push on the door is going to push back on my hand. The door has to apply the exact same amount of force going in the opposite direction. So the first thing we need to do is draw and label all force pairs, assuming that they're standing on level ground. So one thing we can do, or the first thing we can do, is identify that they're standing on the ground, which means that there's a force of Flynn on the ground, which means that the ground pushes up on Flynn. So it's only talking about Flynn and the fact that he's pushing on the ground. That means the ground has to push back up on him, which is perfect because it helps us out with Rapunzel doing the same thing. So if she pushes on the ground, so the force of Rapunzel standing on the ground or she's technically pushing on the ground pushes up on Rapunzel. So the ground's going to do the exact opposite of what the force is pushing down on her. So that means she's going to push back, or the force is pushing down the ground. So the ground's going to push back up on her. Okay, so that's 2 force pairs. Another one we can talk about is right here, specifically her hands. We can see that she is pulling back on her hair. Okay, so this one was the trickiest one to remember, the fact that if she's pulling back on the hair is going to pull this way on her. So the hair pulls back on Rapunzel. Okay, we're not talking about Flynn Rider at all with that one. If she's pulling on her hair, the hair is going to pull back on her. So we feel that tension force happening. Okay, so it's not even about actually labeling forces. It's about what's happening. The action, what's the reaction to that? If you do something that to some object, that object's going to do the same thing to you. So if you push on your iPad, the iPad is pushing back on your hand. If you are lifting an object up, so you're lifting up your chair, the chair is going to be trying to push back down on your hands. Everything has a reaction to your action. So if he is being pulled by the hair, Flynn is pulled by the hair. The hair, or Flynn, sorry, Flynn pulls back on the hair. So if he's being pulled by the hair, he's going to pull back on the hair, which is why he could stand still. Or else if he was being pulled with more force than he was pulling back, that's when we have that unbalanced force and he goes flying. So now question 2 says, explain how Newton's third law is being demonstrated in using each of the terms. So we can talk about action reaction pairs is the fact that every action has to have an equal and opposite reaction. Such as Flynn pushing down on the ground. So the ground pushes back on Flynn, pushes up on Flynn. All right, so now we've talked about action, reaction. So the action reaction pair. Okay. And if we wanted to be more specific, the force pushing down is the force of gravity or the weight of Flynn Rider, which is 934 newtons. Now we've talked about the force, which is really the weight. And we can even go a step further with that same example with talking about the fact that these are balanced forces because he's not going through the ground. And he's also balanced forces because he's standing still. The forces are balanced because Flynn is not moving, but if the forces Rapunzel applies to her hair are larger than the forces Flynn applies to the hair. The forces become unbalanced and Flynn moves to the right with an acceleration. So now we've just thrown all of those forces, balanced, unbalanced, and acceleration. So now we brought in all those terms. So I know it's a lot, but now we've talked about the fact that for every action, there's an equal and opposite reaction. So we know about this equal and opposite reaction. And the fact that he's pushing down the ground, so the ground pushes back up on him. So we've given an example of that, given an example of what his weight is actually doing. So and if we think back to what we talked about afterwards, those forces is going to be our gravity versus our normal force, really is what it is, because he's pushing down the ground. So the ground has to push back up on him with the same amount of force to make it balanced. All right. If you have any other questions, please send me messages or ask on Monday before the summative.